This video will discuss how to find axis intercepts for a line and how to use those intercepts to help you find the slope of a line. The first couple questions we want to look at involve the coordinates of points on the axes. So the first question is, for any point that's located on the x-axis, what do you know about the y-coordinate? So let me just draw a very rough sketch of an axis system, and let me put a couple of points on the x-axis. And I don't really have a grid here, so I don't really know exactly where these points are. But if I were going to label this first point right here with coordinates, I have no idea what the x-coordinate is because I don't really have a grid, but I know the y-coordinate is 0. And for this other point over here, I also don't know what the x-coordinate is, but I know the y-coordinate is 0. And that's true for just about any point on the x-axis. So when you're on the x-axis, the y-coordinate is 0. And if I do the same thing, draw a very rough sketch of an axis system here, and I look at the y-axis points, put a couple of them on here, some above the x-axis, some below, even at the origin. For all of these points, if I were to choose this point right here and try to label the coordinates, I know the x-coordinate is 0, but I don't really know what the y-coordinate is. It's positive because it's up from the x-axis, but I don't know what it is. And the same thing here. I don't know what the y-coordinate is, but I know the x-coordinate is 0. And that's true at all of these points. X-coordinate 0, y-coordinate something else. So on the y-axis, we know that every point has an x-coordinate of 0. So you'll notice that whatever axis you're on, it's the other coordinate that's 0. Now, what is an intercept and how do we find one? Well, we know that when we're graphing lines, sometimes they go uphill from left to right, sometimes they go downhill from left to right, sometimes they're vertical, and the idea is that no matter what direction your line is going, sometimes they cross the axes. And when they cross the axes, that's what we call an intercept. Not sect with a C, but sept with a P. So x-axis intercepts are where any graph crosses the x-axis, and y-axis intercepts are any places that your graph crosses the y-axis. And then if we combine these two ideas, what we had about coordinates being 0 and intercepts, we know that if we want to know where a line crosses the x-axis, or if we want to know the x-intercept, we're going to set the other variable, that's y, equal to 0, and solve for x. And if I want to know where a graph crosses the y-axis, well, if it's on the y-axis, the other coordinate's 0, so I'm going to set x equal to 0, and then I'm going to solve for y. So that's going to be the strategy that we use to help us find intercepts and then graph lines. So if I use this strategy to graph this line, the strategy is going to be to figure out where the graph crosses each axis and then connect the dots. So I'm going to make a little table over here of x and y values, and my equation is 2x minus 5y equals 10. Just looking at that, I don't know where it crosses each axis, but I know that if I want to know where it crosses the x-axis, I'm going to set y equal to 0. So over in my table, I'm going to put a y equals 0, and that's going to leave me with 2x minus 5 times 0 equals 10. But this whole piece is 0, so that's equivalent to 2x equaling 10 or x equaling 5. So that's going to be one of my points, 5, 0. That's over here. And then if I go back to my original equation and I say I want to know where it crosses the y-axis, that means I set x equal to 0. So over here in my table I'll put an x value of 0. Then I'm going to have 2 times 0 minus 5y equals 10. This first term is 0. So that's going to be negative 5y equals 10, or y equals negative 2. So I can fill those points into my table. And once I have 2 points, then I have enough to graph the line. So just drawing this line. This is 2x minus 5y equals 10. Let's take a look at a couple more. So this is a different equation. This is y equals 2x minus 4. And it says to graph using the intercepts. So I'm going to use the same strategy. If I want to know where it crosses the x-axis, I set y equal to 0. And if I want to know where it crosses the y-axis, I set x equal to 0. So for this first one, if I set y equal to 0, I get 0 equals 2x minus 4. If I solve that, I get 2x equals 4. And then divide by 2 and I'll get x equals 2. So that's the point 2, 0. If I want to know the y-intercept, that's this one where x is 0. Go back to my equation, y equals 2x minus 4, and I plug in x is 0. 2 times 0 is 0, so I get y equals negative 4. So if I put that point on my graph, then I have enough to draw the line. And this is y equals 2x minus 4. Now, there's an additional question here. What is the slope of the line? And if I change colors here, and I remind you that slope is the rise over the run, and I imagine myself moving between these 2 points, I need to rise 4 units and run 2 units. So my slope is 4 over 2, or 2. We'll come back to that in a minute. Let's look at one last one before we see the connection here. So I have y equals 1 minus 1/3 x. So making my table for intercepts, you need where they cross the axes. So I'll start with an x-intercept, which means I make y 0. If I make y 0 here, I get 0 equals 1 minus 1/3 x. I think I'm going to move this negative 1/3 x here over to the other side of the equation. So this would be a positive 1/3 x equals 1. And then if I multiply by 3 to solve, I get x equals 3. So that is the x-intercept. And the y-intercept, I make x 0. So that's going to be y equals 1 minus 1/3 times 0. And you'll notice that you get y equals 1. So this one has a y-intercept at 0, 1, and then that's enough to graph my line. And if I want to find the slope here, I'm going to start at this point on the y-axis and move to this point on the x-axis. I have to go down 1 and to the right 3. So my slope, rise is negative 1 because I went down 1. My run is positive 3 because I went to the right 3. So my slope is negative 1/3. Now what I want you to notice here is that this slope of negative 1/3 was actually in the equation right here next to the x. And the 1 that's right here, that's the constant term, That's one of your intercepts. It's the y-intercept. So this right here is the y-intercept. If I go back to the previous example that we had, when I found this slope of 2, that is actually in the equation right here next to the x. So that's the slope. And this -4 that you see here, that ended up being one of your intercepts, your y-intercept. So that is also in the equation. That means the slope is always the coefficient of x if your equation is solved for y, meaning it just says y equals. If your equation isn't solved for y, you can't see the slope and the y-intercept right away. And again, this equation is solved for y. The slope is the coefficient of x, the -1/3, and the y-intercept is the term without the variable in it, or the constant term. So to summarize, if you want to find an x-intercept for a line, you set the other variable equal to 0. So that's, you set y equal to 0 and solve for x. If you want to find a y-intercept, you have to set the other variable x equal to 0 and solve for y. And that what we saw in a couple of examples here is that if the equation is solved for y, and this is a big if, meaning it starts out y equals, then the number that's next to the x is the slope, and the number that's by itself without a variable is the y-intercept. So if you have y equals mx plus b, b is the y-intercept, and m is the slope.